Ever wondered why electricity is always available, day in and day out, regardless of where you are or what time it is? This isn't some mystical creation or supernatural phenomenon, but the result of an intricate tapestry of innovation, collaboration, and the tireless work of engineers around the globe. It's not a magical incantation or a wish granted by a genie in a bottle, but rather a symphony of modern engineering that keeps the pulse of our electrified lives beating without skipping a beat. This is the tale of the electrical grid system, a silent hero, unobtrusive and often unnoticed, but serving as the backbone of our digital era. This complex network of power stations, transformers, and transmission lines spans continents, bridging gaps between cities and even nations. Like a giant, invisible web, it envelops our world, silently pulsing with the flow of electrons, its energy felt, but its structure rarely appreciated. Let's think about it. What does it take to ensure that when you flip a switch, a light illuminates instantly, or when you plug in your phone, it begins to charge immediately? It's an intricate ballet of demand and supply, constantly adjusted and carefully balanced to ensure seamless service. This is the power grid at work, a marvel of planning, logistics, and real-time adjustments. It's a testament to human ingenuity and the drive to make life more comfortable, more convenient, and more connected. This system, which we often take for granted, is the result of countless hours of meticulous planning, design, and execution, all aimed at keeping our lives running smoothly. But the story of the electrical grid isn't just a story of engineering prowess. It's also a story of resilience and adaptability. With the advent of renewable energy sources, smart grids, and decentralized power generation, the face of the electrical grid is changing, evolving to meet the challenges of a rapidly changing world. So sit back, switch on a light, charge your phone, and dive into this fascinating journey of how our world is kept powered and connected. This is no small feat, and we owe it to the countless unsung heroes who work tirelessly behind the scenes to keep the lights. The first and most significant advantage of an interconnected grid is increased reliability. If any power plant stops, the grid manages the load of that. This shared load system leads to a more stable energy supply. Another advantage is peak load exchange. If the peak load surpasses the capacity of a station, the grid carries the extra load. This avoids partial load or expanding the station's capacity. Furthermore, the grid system uses old, inefficient plants for short durations to meet excess demand. This usage allows these old plants to be productive instead of idle. Besides, the grid serves a greater number of consumers than a single station. This wider customer base decreases load fluctuation on the grid, leading to more stable loads on stations. With stabilized loads, the capacity of the generating station can be chosen so that the plant can run nearly at full capacity for longer periods. This optimizes energy production, making it more cost-effective. Lastly, the grid system enhances the diversity factor of each connected station. This diversity factor improvement happens because the maximum demand shared by the station on the grid is much less than if it runs alone. Summarizing, an interconnected grid system brings several benefits. It boosts the reliability of the power system, allows peak load exchange, utilizes inefficient plants, serves a wider consumer base, and improves each station's diversity factor. Lastly, I have a question for you. Can you think of any other benefits of an interconnected grid system? Please share your ideas in the comments. If you found this video helpful, kindly give it a thumbs up and don't forget to hit the subscribe button. Until next time, keep exploring.